Much of research conducted on sensation perception is conducted on the visual system, and a prominent theory of visual perception involves feature analysis, feature detection, a feature detector. So let's talk a little bit about that because it has some implications and has produced at least two theories of perception, one called top-down processing, the other called bottom-up. So feature analysis is the theory that we detect specific elements and assemble them into a more complex form. For example, feature detection or feature analysis says that we're going to put this red octagon together with the letters S, T, O, P, and what we do is we combine all those elements of our visual experience into a stop sign. Okay. Now the evidence for support of this comes from some very, very critical work done by Hubble and Wiesel that found neurons in the brain that reacted to certain features of stimuli. So, for example, vertical lines and horizontal lines produced different levels of activity in certain areas of the brain by certain neurons. So a vertical line here stimulated some neurons, and some neurons were firing, but other neurons weren't. And then when they changed the orientation of the line to a horizontal line, some other neurons, different neurons, fired, but the ones that had fired during the vertical lines did not. So they called these neurons feature detectors, and there were a number of them, and that was pretty cool stuff. So this illustrates bottom-up processing, or the theory of bottom-up processing, and that is the perception proceeds from individual elements up to the whole. So we detect forms and edges and colors and letters and so on, and we build up from that to an image or a perceptual experience. Now, there are exceptions to this. For example, if we were to talk about these features, what we have here are three Pac-Man. But most people see more than just three, red Pac-Man. What they also see is we also see a triangle in here. And the triangle is not a feature of this perceptual experience, but at least from the bottom-up processing point point of view. So we got some exceptions there. Another exception is this message, for example. If you can read this message right here, I'll give you a minute. And if you can make sense of this, a lot of people see this sentence as this message serves to prove how our minds can do amazing things. In other words, if our perceptions build from the bottom up, then 7H15 should be meaningless. However, many of us see the word this in this particular context. We see something different than just the individual elements of this stimulation. We also see message maybe in the word M3554G3. You can sort of see message in there. So that called into question bottom-up processing, and some other folks proposed a top-down processing model of visual perception. An alternate theory provided by the Gestalt School of Psychology argued that what we saw were the whole rather than just a bunch of parts. Evidence for this, they suggested, included things like animations or cartoons. Each one of those, a cartoon or an animation that you see on TV, or if you see in the theater, any sort of movie, any sort of animated movie, is a series of static images that are shown to you in rapid succession. And this produces what's called the phi phenomena, and that is you perceive motion as these images are rapidly presented to you. So, has this issue been resolved? Well, the Gestalt theory of psychology is not real active at this point in time. We tend to think that there are elements of truth in both of these things. The research now has sort of focused on more about how does a two-dimensional upside-down image on your retina get turned into a 3D thing? How do we perceive these real things how do we see them in 3 dimensions? How do we sense them in 3 dimensions when they're really just a 2-dimensional stimulation in the back of the retina? One of the issues that I think is most interesting, and there's a lot of issues that need to be resolved in this, and there's a lot of debate about this. There's another school of thought in perception called direct perception, which deals and criticizes much of sensation and perception research on this basis. But I want to show you how some of these things come into play and some of the questions that are interesting in sensation and perception research. One issue is, how do we see depth? Now, we most of us know that or have heard that we see depth because we have 2 eyes. Okay, 2 eyes produce binocular cues. Bi meaning 2. Um, so we see depth because the images on our 2 retinas, we have 2 retinas, one in the back of each of our eye. Each of those images is slightly different because it's, spatially speaking, our eyes are set apart a little bit. Okay, so this produces depth. However, depth can come from monocular cues as well. Depth and distance can be inferred by certain properties of light and place. And I want to show you an example. So if you think that binocular vision is what gives us depth, there are other examples as well. There's monocular cues that help us with depth perception as well. And we've known these for years, for centuries in fact. Leonardo da Vinci, suggested that different shades of purples could represent depth in landscape paintings. The lighter shades are the farther away, and that gives us depth cues. And this is a picture of a mountain range, and you can see how sort of they're purple, but they get lighter and lighter as they get farther away. This is a painting in which a person has used that principle. So the visual system is pretty complicated, obviously, and we've learned a number of features about this. So hopefully that clears up some issues of feature analysis and bottom-up and top-down processing. There still are unanswered questions, certainly, about this, but very interesting ones, like the issues raised by Da Vinci.